In section 4, we're going to talk about the rational roots theorem and real zeros. So we're going to see if we can find the roots and zeros of our polynomials. This includes real zeros and any complex zeros we may have. So the first thing we're talking about is the number of real zeros theorem. So what the number of real zeros theorem tells us is that a polynomial of degree n has at most n distinct zeros. So my degree determines the number of zeros we have. We also have the rational zeros theorem. So what that tells us is that if p of x is a polynomial with integer coefficients and if p divided by q is a zero of our polynomial p of x, then p is a factor of the constant term of p of x, and q is a factor of the leading coefficient of our polynomial p of x. So p and q come from the factors of our leading coefficient and our constant, and then their division gives us our potential rational zeros. So any value that could be a zero. It helps narrow down potential zeros for us, and we could find, so of those choices, we know whatever our degree is, a certain number of those have to be a zero of our function. So let's go ahead and apply our rational zeros theorem. So we want to list the possible zeros of our polynomial f of x equals 2x cubed plus 11x squared minus 7x minus 6. So we're going to list the possible rational zeros of the polynomial f of x equals 2x cubed plus 11x squared minus 7x minus 6. So first we want to identify p and q. So p are the factors of our constant. So our constant term in our polynomial is -6. So when we talk about its possible factors, we have to talk about positive and negative factors. So I know positive and -1 are potential factors. I know positive and -2 are potential factors. Positive and -3 are potential factors. 4 doesn't go into 6, 5 doesn't go into 6. The last potential factor is positive and -6. So those are all the potential Those are all the factors of 6. Now we have to find the factors of q. So q is our leading coefficient, which in this case is 2. So the potential factors of 2, there are only 2 of them, both signs, positive and negative 1, and positive and negative 2. So to find our possible rational zeros, that comes from doing p divided by q. So p divided all of the all the factors of p divided by all of the factors of q give me my possible rational zeros. So we start by taking plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and dividing them all by plus or minus 1. And when we do that, we get the exact same thing as we originally had. So plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Next, we have to take all of our values we got for p and divide them by 2. And anything that we see repeated, we don't list again. So we start with 1 divided by 2. So that gives me plus or minus 1/2. We then do 2 divided by 2. Well, that gives me 1 again, which we've already listed, so we don't list it a second time. Now we take 3 and divide it by 2. I haven't listed that yet, so we get plus or minus 3 divided by 2. And then if I were to divide 6 by 2, I get 3 again, which I've already listed. So positive or negative 1, positive negative 2, positive or negative 3, positive negative 6, positive or negative 1/2, and positive or negative 3/2 are all the possible rational zeros of our polynomial. There could be some complex zeros that we don't know about, but these are the only rational zeros that we can have. So now we actually want to know which of these are actually zeros of our polynomial and how we can determine this with the function and its graph. So if we were using the function, we could start testing these possible values using the remainder theorem and then using synthetic division to get our way to a quadratic that we could factor. Or we can just graph them to figure out how many of those are real zeros and then use the quadratic synthetic division or quadratic formula to find the rest of them. And if I graph the polynomial, I can determine how many real zeros we have. And we have 3 real zeros, so we don't have to do anything further to find any of the other zeros. So negative 6, negative 1/2, and 1 are the actual real zeros. So negative 6, negative 1/2, and 1 are the real zeros. And because it was a degree 3, there are only 3 zeros. We have all 3 of them. We know there aren't any complex zeros. So now we're going to try to find all of the real zeros. So this is going to include rational and irrational roots. So something that may involve I. So if we don't have all real zeros, we may have to use the quadratic formula. So we're going to start by finding all of the rational zeros using the rational roots theorem. And then we can continue from there to find all of the real zeros. So looking at our first example, we want to find all of the real zeros of f of x equals x to the 4th minus 15x squared minus 10x plus 24. So we're going to start with listing the potential zeros. So p, my constant is 24. So that means all of the factors of 24 are potential real zeros. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and lastly, plus or minus 24. So those are all the factors of P. Now we go to Q. Well, my leading coefficient is just 1. So its potential factors are plus or minus 1. So when I do P divided by Q, pretty much dividing all of my factors of P by Q. So I'm just going to get the factors of P again. So instead of rewriting them out, I'm just going to have you look up here at P. So instead of having to rewrite all of those factors out again, since I'm just dividing them all by 1, I'll get the exact same thing as I got for P. So those are all the potential real zeros. So to find them, we first look at its graph. So when I look, it crosses the x-axis 4 times. So all of our real zeros are rational zeros. None of them are irrational. So our real zeros are going to be at -3, -2, 1, and 4. Okay. Now we're going to have to do some division. So I want to find all the real zeros of g of x equals 4x to the 4th minus 15x cubed minus 8x squared plus 15x plus 4. So we start with the factors of P. P is 4. Well, the only factors of 4 are 1, so plus or minus 1, 2, so plus or minus 2, and 4, so plus or minus 4. Okay. Q is also 4. My leading coefficient is also 4. So it's got the same factors, plus or minus 1, plus or minus 2, and plus or minus 4. So now we actually want to do P divided by Q to get all of our potential factors. So our first number we're going to divide by is 1. So when I divide all of the factors of P by 1, I get the exact same. So I get plus or minus 1. Plus or minus 2. And plus or minus 4. Now I divide my factors of P by 2. We get plus or minus 1/2. 2 divided by 2 is 1, so I don't write it a second time. Sorry, 1 divided by 4, skipped 1, so we have plus or minus 1/4. Right. Now we move on to 2. Well, 2 divided by 2 is 1, which we've already written, so we don't have to rewrite it a second time. 2 divided by 4 is 1/2, which I have already written, so I don't write it a second time. Then we do 4 divided by 2, which we have already written, so I don't write it a second time. And then 4 divided by 4, which is 1, which we've already written. So the only potential rational zeros are positive and negative 1, 2, 4, 1/2, and 4. So we move to the graph. We see that it has 4 real zeros. They're all rational zeros. None of them are irrational. So my real zeros are going to be at -1, -1/4, (1) and 4. So now we actually want to solve a polynomial. So we want to solve x to the 5th minus 6x to the 4th minus 6x cubed minus 4x squared minus 27x plus 42 equals 0. And we want to think about how this problem is the same as the ones above. So if I'm solving a polynomial, it's the same thing as finding the zeros. So it's the same process as what we've been doing. We first find the possible rational zeros. We figure out how many rational zeros we have, and then we can work our way from there. So if we look, we want to first list the possible factors of p. So my constant in this case is 42. So the possible zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 7, plus or minus 14, plus or minus 21, and of course, plus or minus 42. I notice Q is, our leading coefficient is just 1. So its factors are plus or minus 1. So when I do P over Q, I'm just going to get P again. So the factors I've listed for 42 are all of my potential rational zeros. So we then move to the graph to figure out how many real zeros we have. And if we look, we have 3 real zeros. We have real zeros at -2, 1, and 7. So -2, 1, and 7 are my rational zeros. We still want to find the other 2 zeros. They're irrational. So to figure out our irrational zeros, we have to work our degree 5 polynomial down to a cubic. And because we know -2, 1, and 7 are zeros, we can use those values in synthetic division to get a quadratic, which we then can use the quadratic formula on to solve. So let's first start with -2 in synthetic division. So we have -2. Then we put our coefficients, which are 1, -6, -6, -4, -27, and 42. Always bring down that first term. -2 times 1 is -2. -6 plus -2 is -8. -8 times -2 is +16. -6 plus 16 is 10. 10 times -2 is -20. -4 plus -20 is -24. -24 times -2 is -48. Sorry, +48. -27 plus 48 is 21. And 21 times -2 is -42, giving us a remainder of 0. So instead of having to rewrite that as a new synthetic division problem, I can continue with my next 0. So our next 0 we know we have is 1. So I can go ahead, I'm going to put 1 here now. Okay. I'm going to draw a new line. I'm going to bring down my coefficient. Because these are the coefficients of my degree 4 polynomial, I don't have to rewrite it for the synthetic divisor. So bring down 1. 1 times 1 is 1. -8 plus 1 is -7. -7 times 1 is -7. 10 plus -7 is 3. 3 times 1 is 3. -24 plus 3 is -21. -21 times 1 is -21. We have a remainder of 0 again. And again, I can just keep going to get my quadratic. This should be the last 0 that gets me my quadratic, and the last 0 we have is 7. So bring down the 1. 1 times 7 is 7. -7 plus 7 is 0. 0 times 7 is 0. 3 plus 0 is 3. 3 times 7 is 21. -21 plus 21 is 0. So the quadratic I end up with after I use synthetic division to factor out my known zeros is x squared plus 3. And we don't actually have to use the quadratic formula to solve this quadratic because I can use the square root property. So when we're solving our quadratic, we have x squared plus 3 equals 0. We subtract 3 from both sides. We get x squared equals -3. Take the square root of both sides. We end up with x equals plus or minus We've taken the square root of a negative number, so we have to include I. We can't simplify the square root of 3, so we end up with square root of 3. So the last two zeros we can add to our rational ones are positive and negative I radical 3. So I'm going to go up here and write them. So we have I square root 3, and we have negative I square root 3. And those are that gives us all 5 of our zeros for our degree 5 polynomial. We have one last zero. We want to find the real zeros of x cubed plus 2x squared minus 1. So again, we're going to start with listing all of the potential rational zeros. So our coefficient, our constant, p, is 1. So its factors are positive and negative 1. Our leading coefficient is 1. Its factors are positive and negative 1. So my only potential rational zeros are positive and negative 1. And if we look at the graph, we know our rational zero is negative 1. We do have 3 real roots that are all real numbers. I don't have any irrational, but my other 2 are going to be complex, which means I'm going to have to use the quadratic formula to find my other 2 zeros. So I know one of my zeros is negative 1. All right. Because it's a cubic, we only have to use synthetic division once to figure out what our quadratic is, and which we can use the quadratic formula to finish solving. So if I set up my synthetic division, negative 1 is a known zero. Then our coefficients, 1x cubed, 2x squared. We don't have an x term, so 0, and negative 1. Bring down the 1. 1 times negative 1 is negative 1. 2 plus negative 1 is 1. 1 times negative 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is 1. And we get 0 as our remainder. So the quadratic that we're going to use for the quadratic formula is x squared plus x minus 1. So when we plug it into the quadratic formula, we get x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 1 all over 2 times 1. So we get negative 1 plus or minus 1 plus 4, because negative 4 times 1 times negative 1 is positive 4, all over 2. So our last 2 zeros are going to be negative 1 plus or minus the square root of 5 all over 2. And if I were to use a calculator to get the decimal answer, I would end up with the same decimals on my graph, negative 1.618 and 0.618. But we really don't like writing decimal answers. We want to leave it in as that answer. So if we go back up to finish listing our zeros, we have -1. We have -1 plus the square root of 5 over 2. And we have -1 minus the square root of 5 over 2. And those are all 3 of my zeros for my cubic.